a flash. Alright, so what I want to do is disassemble my Ender 3 motherboard. And the reason I'm doing this live is mostly so that I can document it rather than recording a video, which hopefully I have enough battery to do on this phone, which I actually should plug it in before I do anything else. But in the process of trying to figure out what has gone wrong, I have only made it worse. So let me just quickly demonstrate what I mean. I turned the power on. I double checked all my voltages are correct, but it seems I've blown a main fuse somewhere near the back of the board, which you won't even be able to see. And so now not even the lights, the little lights come on. They did come on before. They're right kind of where the LCD display is, and the LCD, even if it's plugged in now, it doesn't even come on. The buzzer doesn't come on. The motherboard is just completely dead. The only thing that's still getting power is this fan, which I don't know why. I don't know if it's running off its own power. I thought it was. I mean, even this fan's not turning on, so I thought this fan. Oh, I believe this fan and this fan are connected somehow, so they have to both be turning. So only that fan's working. So yeah, we're just gonna go ahead and start to disassemble the motherboard here. And what I don't like that they did with the motherboard is they hot glued everything down, which, I mean, it's kind of good, but if you want to change things, like for me, I'm replacing the whole motherboard because it was faulty, you know, it's not as nice. Oh, and I better turn it off before I start messing with anything. And just as an extra safety precaution, I'm going to unplug the power back here. Get to unplug those. Oh, jeez. So now there's no way, theoretically, for power to reach the motherboard. It's actually not a great place to put this. I don't want to have it upside down. What was I doing before? I was using my mic stand. Rather than use my mic stand, I thought this was going to be good enough, but maybe it's not. Because it looks like it's too close and the camera can't focus. So I need a way to raise this up. Like this. It's actually almost perfect. Just gonna move this axis out of the way a bit more. Slowly raising the axis. Okay. Yeah, so we've already tried to see what some of the potential faults were. So I actually used my little side cutters here to clear away some of the glue. But if I can rotate this, you should be able to see there's still a big mess of hot glue there. So I've cleared off these two pins, but there's still a lot here, so we're going to take our time and basically finish that process. So immediately what we can do is take out these two wires, and they're not actually labeled. So, sorry, I got a text. I should probably turn that off so I don't get any more. So we're gonna take out these two wires here. One of them is the temperature sensor for the, I think the bed, and the other is a temperature sensor for the extruder. So I think this E temp would be extruder temperature, and this B mot might be bed MOSFET or something. So we're going to pull this out. And we're going to grab some electrical tape. We're just going to wrap it. Like that, and then I don't have a good pair of scissors, so we're just going to cut it like that, and then wrap it again. And now these two we know are different. You can probably just barely see. So now we know that this black one is our E-temp, extruder temperature, and this non-labeled one, completely unlabeled, is our BMOT, or bed MOSFET. And you can probably see right here is the dead chip. So now we're going to unplug the bed MOSFET. We try to be careful because we're definitely reusing these plugs in the new motherboard that's going to come. It's a stock motherboard, so a lot of people suggested just get an upgraded motherboard, but all the different motherboards that I was looking at, you need to do something to them, basically. As in, you need to wire in stepper drivers or all this other stuff, and really I don't really want to get to that stage yet. I don't think I'm at that stage in my ability to modify stuff. Okay. Second really easy and obvious thing we could do is to take out this ribbon cable for the LCD display. There is a big glob of glue on the side, so we're gonna have to get rid of that. So making sure to avoid touching any of the electronics as much as possible, we just use the side cutters to basically grip the glue. And this is probably not the most professional way to do it. I'm sure some people would suggest maybe heating up the glue first, but we don't want to heat up this plastic because that wouldn't be any good. So just using a screwdriver to pry the hot glue away. And maybe our needle nose pliers would be more useful here. So in fact, I'm going to go grab those. Okay, well, to be honest, these needle nose pliers that I have are quite bulky, so I don't know how much better they are going to be. There we go, we successfully removed this piece of hot glue. Set it aside to throw it out later, but now we should just be able to, boom, pop this ribbon cable out. And we can see the connector goes into this one. We shouldn't have any difficulty getting back in here later. So we're going to set that aside. Now these ones all along here are pretty close together, and again they're all glued, so it's going to be kind of annoying to try and take those out. So instead I think I'm going to focus on this side with all the extruder motors. There we go, got the hot glue out. And we should just be able to gently pop this motor out. And this was the E for extruder motor, and we can see the E here and the E here. So that will be easy to reassemble. So onto the Z stepper. Hot glue comes off and pry the switch out. Then for the Y stepper, again, hot glue is out, and then the actual switch comes out just like that. And for the last stepper motor, there we go, and out. Okay, so that concludes the stepper motors. So as you can see, they all do go off into this zip tie. And I could cut the zip tie, but I'd rather keep them more or less organized for when I put them all back. So I'm just going to kind of gently bend them out of the way so that they're mostly out of the way. And then, I don't actually know what this is. It says fan 1. And if I look at it, this actually goes and connects up here. These blue yellow wires, they actually do go up there. So that is the cooling fan for the plastic, not the extruder. So another glob of hot glue. Try not to put any stress on the wires, just the plastic. So here we go, inspecting it, looks fine. I didn't actually see it working, to be honest. Now we move on to the stop switches. So this first one is the Z stop switch. And this has one really large glue all along the back. And we might just be able to take it off all in one piece. There we go. We actually did manage that. So put that aside. Now we should just be able to simply, let's see how bad this is to do with my pliers instead of my hands. Grabbing the plastic instead of the wires. I don't think this is effective. Or I could just be putting some little force into it, then it's basically. Okay, but the we got the Z end stop out. I'll go for the next one. That was easier, much easier. This is the Y end stop, and that should be our last one here. This one's much harder to get out. This should be our X end stop. And it is, okay. Now we have our motherboard fan, So that one should be pretty easy to put in as well. So put this switch off to the side. These things are kind of hard to pull out. It's like pulling a tooth. There we go. Okay, so that is out. We can put that out of its cage. Okay, so that does it all for all of the simple plugs. Now we can go see what we burned back here. And it looks like some kind of, maybe a little MOSFET of some kind. I can't really tell. But this right here, it's not focusing on it. We were trying to test some things, and we accidentally caused a short here. This one was our fault, but the chip was already dead, so this has no bearing on our problem. But burning this chip out means that none of our lights and stuff work anymore. So presumably that has some relation to the power, although it doesn't affect the main fan power, which is probably one of these here. So we're pretty much ready to move on to these. And I'll do the ones that are probably the easiest to make sense of. So these two are our extruder heating elements. And I think it doesn't matter which way they go because they're a heating element, so they can go either way. So we're gonna just unscrew. Get out of here. Unscrew these. I don't really know how much they have to be unscrewed by to get them out. I'm sure it's going to take me at least an hour to put the new motherboard in because I'm going to be super cautious. So we have just our 2 wires. There's nothing fancy there. They can go aside. Okay, now we have 2 really fat wires, and I'm pretty sure this is our heated bed. It might even say somewhere, but I'm not sure because this this wire, these 2 wires here, had no voltage when it was plugged in. They were completely just dead, basically. And I'm assuming that's because there's no voltage sent to these wires if the bed is off. That makes the most sense to me. And then back here is our power in cables, and this one is our main fan up top that's always on. So we'll see about that. I want to do a test now with all of these things unplugged, but I'm a little concerned that having all this exposed wiring will fry one of them. You know what? Let's not even bother because we don't want to risk frying anything, including ourselves. And I'd have to go plug the motherboard in again. Okay, so these really big wires, there's a black and red wire. It looks like it's a skinny red wire, but it's actually partially black. So we're going to take that out. And then the main red wire. I forget if it's ground before power in electronics cases, or if there's some saying for that. So these should just, yeah. There again, they just press fit basically. So they come out of there as well. And now lastly, we can take this fan out. Well, not lastly, there's still one more thing to do after this, which is the main power, but this is the last component to take out. So we're really getting into these wires here. And the power. This one's really stubborn, what the heck? Oh, I think I got it. Okay. And these two just... oh, they should pull out just as easily as the other ones. Okay, there they are. So, yeah, I have it on video which was where, so that's fine. Okay, now we can move all of these other wires aside to get to the main power input for our board, which is this puppy. So power on the right, ground on the left, or positive and negative, whichever terms you'd like to use. Guitar string. Just kidding, it was a belt. Okay. I'm going to have to do this the other way because that's the way I've been doing all of them. Okay, theoretically, just like the other ones, they should, for the most part, just kind of pull away. Alright. So now that's done, we can actually have a look at our board. And, you know, normally when you're looking at the machine, it's sitting like this. And, well, you know, we can notice a few problems. There's another YouTuber that actually did a pretty good job on spotting all of these other issues. So there is actually insulation on all of these four heat sinks up here. That's good. But this one really big heat sink looks like it barely has any insulation, and it's too big. It's sitting on top of another chip, which is also like not a good design. Why would you put your cooling on another chip and not give that other chip insulating stuff? So looking at it from the side, we can see our sort of all our pins there. 3DV 1.1.3, so hopefully the new one that comes in is also a 1.1.3, but we might do the Marlin firmware upgrade because we already have, you know, a board exposed, but we will have to pick up an Arduino, unfortunately, in order to accomplish that upgrade. And that's okay because I was thinking of maybe putting Octopi on it anyways. Maybe I should move this Z limit switch up so that it can't go down as far, but then I'll have to raise the bed up every time, like to its max setting, and I don't think that's the best thing to do either. Okay, so let's look at the damage. So, depending on how well my camera focuses here, there's the fried chip, and that's how it looked like when it fried. Went up in smoke, boom. That's where the QC funny enough. Let's see what happens if we peel off this QC sticker. Are we gonna see some nasty stuff underneath? Was this like strategically placed QC sticker. Pros QC sticker placement. Okay, so I took it off, and I'm assuming this, I can't even see it. This cluster here is is where our chip was. So this, well, where our chip is, but where our chip was fried. And I don't know if I could find it from underneath. I don't see any damage underneath. So I don't think it has anything to do with sort of the printing of the board. Things are shaking, and I'm assuming they're just the screws. Yeah, I think it's just the screws. But this board up here that we fried. Now, this board, somebody sent me the schematic, and basically they traced these lines back to find out, well, what could have caused this. And it looks like from where it fried, if you follow this back here, looks like it comes to here, and it's this BMOT, which is the bed MOSFET, somehow fried the chip. And the only way that could happen is if there was too much current on this thing. Now, I was using the heated bed on my first print to try and, have a nice first print. I thought, oh, I have a heated bed, might as well use it, right? So it's possible that somehow in my bed wiring it's no good, and so I'm probably going to take apart my bed while I'm waiting for the parts to come in. My biggest worry is that I'm going to damage something further that's not just the motherboard. Like, I just did this today when I was testing things, trying to see where my issue is coming from, and now I know that this bed sensor is 5 volts, and it's only 5 volts. So it can only be 5 volts or less, I guess, depending on how this switch works. And it's just a temperature sensor. So I would assume, it has some resistance that less than 5 volts, it can translate that into the actual temperature, because it's like a variable resistor based on temperature, so it's more resistance the higher the temperature is. And so the lower this voltage is, the higher the temperature, because the more resistance is. Now, I don't know if it's measuring resistance or voltage, whatever, but I think the property, or the whatever it's using is based off that. So what I actually could do in here, and I'd have to research this because I don't know if it's possible, but put some kind of diode or fuse so that it can't go over 5 volts, or maybe like 5.5 volts or something, so it has a bit of a buffer. But put it in line with this and not ever allow this to go over 5 volts. That way, if it ever does feed more than 5 volts, or tries to feed more than 5 volts into this switch, it'll blow and it won't fry the chip. So I think that's my best option in terms of not having this happen again. So I need to find some kind of fuse, 5 volt fuse, or some, I don't know what the actual technical term for that is. Something like that. Now what happened over here, I think I just accidentally touched 2 wires together and blew the chip. But I'm not going to worry about that, I guess, too much, because I don't think that'll ever happen during normal operation. Now I could do it on basically all of these, Although I don't know what the voltage limits for these are, but I would assume they're probably all the same because they have the same kind of architecture. So, and if I look at the actual kind of wording here, I don't see anything that indicates yeah, like I don't know what these little things say. Fried chip smells great. And I don't know what these are for. Maybe these are some kind of resistors or something, but they're definitely not enough to prevent that issue. Clearly. So hopefully, I know it's probably really late in the video, I might make a separate comment or something about this, but I need to find